Okay, for your question 8, this is about your generator, your knowledge on Faraday's law, your knowledge on Lenz's law. Okay, for question A, what you need to take note is that common mistake is most students go and write induced EMF is proportional to magnetic field strength. That is wrong. Or some of you may just write that induced EMF is proportional to the change in magnetic field strength. That is also wrong. Okay, it has to be very, very accurate and precise. Okay, the Faraday's laws actually tell you that the induced EMF is proportional to the rate of change. So how fast it changes. It's not just how big is the change. If you simply write down the change in magnetic field strength, what you're saying is that, oh, okay, I changed my magnetic field strength from 0 to 10, but I take 1 hour to change. Now that will give you a very, very weak induced EMF. But if you are changing the magnetic field even from 0 to 0.5, but within 1/10 of a second, the rate of change is so fast, then you will get a big EMF. So it's the rate of change, not just the change itself, it's how fast it changes. Okay, so once you indicate this statement, I'll give you the first mark. Then because of that, if you understand it is the rate of change, then you are actually trying to locate at which point A, B or C will the rod be actually moving at the higher speed. Because when you are moving at the higher speed, you will definitely experience the fastest rate of change, right? Yeah. So at A, basically your velocity is 0 because it's changing direction. So similarly to C, V is 0. So actually your fastest, the rod will move at its top speed when it is in the middle. Okay, another way of understanding this is that A is maximum PE. So at maximum PE, of course, you will have, because V is 0, you have your minimum KE. And when you reach the lowest point, all the PE will be converted into KE, and therefore you have the higher speed. Okay, so at B, the rod is moving at its maximum speed and hence the maximum rate of change of magnetic field strength. So therefore you have the largest induced EMF and largest induced current. Okay, possible modification, you have so much. You can either use a stronger magnet here, you can either you can either release it at a higher position so that there will be a bigger drop in PE and therefore you will have a larger gain in KE here. Another way is to shorten the length of this string. What happens is that when you shorten the string, when you shorten the wire, okay, the period will be faster, the frequency will be faster, and because your frequency goes faster, your speed at B will be faster. So there are actually a number of ways. Okay, mark and label the direction of the current. So what happens is that in this case, you are generating a current, you need to use your right hand rule. So I will just do for A first. So for A, this finger is for your magnetic field. So I should point into the paper. And at A, the pendulum is going to swing this way. So the force is going this way. So rotate your hand and point, use your thumb and point to that direction, and you see that the current is actually going up. This is the current. So A is pointing up. Okay, so indicate the current here. Okay, for C, please work it out, but I can tell you the answer is that it is going down. Okay, go and work out. If you cannot do it, come and look for me. Okay, I will help you. Okay, question 9. I think part 1 I do not need to go through. It is very straightforward. Just use your transformer coil ratio to voltage ratio formula. You'll be able to find it. Now part B, I have written a rather long explanation, and that is because I'm trying to explain this to you. Okay, in exam, if you want to do a bit of shortcut, you can do it. Okay, so what happened is that a lot of students are unable to appreciate this. They may ask me, teacher, why the power dissipation formula must be I squared R? Okay, I will explain that in part C. Okay, so in part B, let's go into part B first. So what happened is that when you are looking at a power grid, okay, of course the cable have some resistance, and then after that this whole power grid is connected to your home. Your home have so many different electrical appliances, some of it turn on, some of it turn off. So you do not know what is the resistance of this entire power grid. There's no way you can know. But what you can tell is that this entire power grid is going to follow a ratio of V equals to IR. Right? Meaning that when you apply V equals to IR to the supply will definitely have some effective resistance which is dependent on your house electrical appliances and all those things. So you don't really know what this R is, and it is always changing. But what you know is that when you increase the V, okay, your I must reduce. Right? Because this R, let's say you take one instance and you say that, okay, at this instance this is my resistance, so your R is equals to V over I. Right? So at this instance your V and your I is constant. So when you have a high V, what happens is that your I must be low in order to maintain that constant R. Yeah? So when you have a high voltage, it implies that in your power grid, you will, at this section of your power grid, it will have a low current. Okay, and because power dissipation by the cable is actually given by P equals to I square R. Now I'm going to explain to you why is it that I use I square R and not V square over R. Okay, this one just hold on for a second. Okay, the power dissipation given by the cable is P equals to I square R, and therefore with a low current you will result in a low power loss. Okay, in the next part, in your part C, I'm going to explain to you why can't I use P equals to V square R to calculate the power dissipation. Because some of you may think that, hey, if I use P equals to V square R, I have a high V, shouldn't that give me a high power dissipation, a high power loss? Okay, so hold that question in your mind. I'm going to explain it in the next part. Okay, so part C. Part C really tests you on your understanding of the whole idea of this power grid, because they give you the 5000 kilovolt. You may think that, hey, how come 5000 kilovolt? Then I have to calculate the power loss. So what is this? And then then the question gives me 1000 kilo ohm. So are you saying that I use this power, I can find the voltage here? So you see, I know some of the doubts that you are having. So let's get this clear straight. So this 5000 kilovolt is actually your power supply, right? This is your power supply. So in your power station is that there will be, of course, a generator. So down here the question didn't tell you what is the voltage. Okay, they didn't tell you what is the voltage, but this question is actually focusing on this part, right? This part here, when your transformer has already changed it into 400 kilovolt. So down here, yes, it is at 25 kilovolt, it is the supply, but after the transformer, it actually changes to 400 kilovolt. So what happened is that apply this P equals to VI to the source. Okay, when I say the source is here, down here, this point, when it is after the transformer. So with that, you can actually calculate what is the current here. Okay, so you already know, okay, this is my current at this point of time. Okay, so then after that, you can now use your current to find out the power dissipation. So now that is the point whereby a lot of you may ask me, okay, so now I know that my supply is 40 kilovolt, and then after that it's going through some cable, so I take this as my cable resistance. So you have some cable resistance, and then it goes to my house, which basically have some appliances here, and then it flows back. So now the question is, why not use P equals to V square over R here? Why can't I use that? My power supply is 40 kilovolt. Why can't I put 40 kilovolt into here? Why? The reason is, your cable resistance is actually connected to whatever appliances in your house in a series circuit. Can you see? It's series, right? There's only one path. Even though yes, down here you branch out to a lot of electrical appliances. But imagine all the electrical appliances, you combine all the resistance into one effective resistor. And this one effective resistor is actually connected to your cable in series. So what happens in series is that your voltage is being shared. So you cannot say that this 40 kilovolt is actually the potential difference of your cable. You do not know. Because, okay, you know that this R is 1000 kilo ohm. But how about here? You do not know. Actually, at any instances, this resistance is going to change. So at any instances, the potential difference at your cable is changing. You won't know. So because you can't tell what is the voltage, you cannot use this formula. Because you can't tell what is the voltage that is on this cable, and it's always changing anyway. So you cannot use that. So what you can use is that you know this is connected in series, so your current will always be the same. Your current will always be the same. So that's why you have to use I squared R. And when you use I squared R, you realize that, okay, my I is going to change irregardless of this. Okay, because that's my supply, right? My supply gives that much current. Okay, so that's why at here, you get your 12.5 ampere here. So just use your I squared R, you will get the power dissipation, and you find that it is really quite a lot. Okay. Part D, explain why alternating current is required. So number one, you have to indicate to the marker that because you have a transformer here, and transformer only works with AC. Okay, then the next point you also must tell is that you need to have this transformer. Okay, so this explanation comes in two parts. Okay, number one, transformer only works with AC, and number two, you cannot do without a transformer. You need to step up and step it down. Okay, so you need two parts. If not, your explanation won't be complete. If you just say that, oh, my transformer needs AC to work, but is your transformer a necessity? If it is not, then why you use AC? Okay, so remember your explanation need to be complete. It must be two part. Okay, you need the transformer, and transformer only works with AC. Okay, part B is your testing your concept about pressure. Down here, explain briefly what happens when air is removed. So start off your answer with when air is removed. So what will happen? The pressure in the tube will actually decrease, and in order to equalize with the external pressure, the column of the liquid must increase in height. So you need to explain what happened when the air. You have to explain like what happened to the pressure, something that you cannot observe with your naked eye, then relate it to whatever that you can see from the system, which is the change in the column height. Okay, then for your part B, what happened, what causes the height difference is because when you look at these two, if you look at the pressure at here, this pressure and this pressure must be the same. So your pressure at A must be equals to pressure at B, and this pressure is due to rho GH. So rho GH. Okay, so why the height is different? That's because your density is different. Okay, one may be higher, one may be shorter. So indicate that, and since it is one mark, you can just stop it here. But if you want to give a really complete answer, look at your equation, and you can tell that, okay, if my HA is large, that means my rho A must be small. Okay, if not, you cannot equal to this side, because this side HP is small. So this guy is big, this guy is small. So big, small, big, small. So therefore this one must be small, this one must be big. Okay. Then after that, at the same pressure, actually there are multiple answers. If you mark this point as a P and this point as Q, you are also correct. Because at P and Q, at this point it is only experiencing the pressure of the air here. And this air column is the same column for both tubes. So because air pressure acts in all directions with the same forces and same pressure, P and Q will be the same. Okay, otherwise you can also say that, oh, okay, my P, let's call this P and Q2 pair. This PQ2 pair, P2Q2 pair will also be the same because same liquid level as the outside. Okay, so multiple answer for your part C1. Part C2 is like what I said. If you indicated PQ, that means this pair, PQ, then the explanation will be that the gas pressure acts equally at all points. Okay, if you indicated your P2Q2 pair, then the explanation is a bit longer. You have to say that because P2 and Q2 is at the same liquid level as liquid level is in the same liquid level of the tank surface, so it's the same surface here. So because of that, they are actually equal to the atmospheric pressure. Okay. Okay, D is actually the mathematical workout that I have written a few minutes before. So what happened here is that you have PA and PB, and quite straightforward. Expand it to rho GH, and if you want to have a really complete equation, actually this PA here, the pressure inside here, okay, actually has also a component of the pressure of the air column and plus the pressure of the air column, but because you are comparing with PA and PB, and this pressure in air is actually of the same value, so they basically cancel each other. So once you have written down this thing, rearrange the thing, because you are actually looking for the ratio of density liquid A to liquid B, so that's why you want liquid B to be in the denominator. So once you do that, do your cross multiplication carefully, you will have the ratio here. You can either leave it in this form, fractional form, or the decimal form. Okay, explain why liquid is used. There are two key points you need to indicate here. Number one is that liquid is incompressible, and you need to explain, so what if it is incompressible? What has this to do with my hydraulic system? What is the advantage of having an incompressible liquid to my hydraulic system? Okay, so don't just stop at liquid is incompressible. You need to relate this property of the liquid to the hydraulic system. Why this property is favorable to my system? So continue explanation. Liquid is incompressible, and therefore it enables the pressure to be transmitted through the hydraulic system effectively. Okay, don't just stop here. Huh? Okay, explain why water is not a good choice. There's a lot of different answers. Water has low boiling point, evaporate easily, cause rusting, has a strange expansion effect. Water below 4 degrees C, it will start expanding, and then if it freezes, it will actually expand and rupture the hydraulic pipe. So many different choices. So as long as you hit one, I'll give you the point. Okay, I think this is the last two questions, so let's make this quick. So there's a lot of information in front. Read through it, understand it. If you look at A, basically they ask you for the function of these two things. It is the same as your generator. So go to your generator chapter. It has the function. Basically, is to keep the wire from entangling itself and keep it in contact with the whole circuit. Okay, all the while it is rotating. Then state the. Then explain why there is cut-in speed. I think that's what they call it, right? A cut-in speed. Yeah, this one. So why is that? It will only start moving when the speed is 2.5. Why can't it be 1.5? Why can't it be 2? So it's actually quite intuitive. the wind must exert enough force, right, to overcome its inertia, or if not, you can say that to overcome the friction between the moving part. Okay, if not, it won't move. It's the same. Okay, you have to, when you are pushing something very heavy, let's say you are pushing the basketball, oh no, that's not good. Okay, let's say you want to push a car. Okay, you must exert some strength and then it's still not moving, right, because you haven't overcome its inertia, or you haven't overcome the friction. Okay, similar to that kind of situation. Okay, for part C, why do you need to control its speed? Control its speed under 15 meter per second. The thing is that nature is untamable. So sometimes there's typhoon and there's things like that. And when this happens, the rotation speed will get really out of hand. It will spin so fast that the generator will generate really a lot of current. And the current and the cable or the circuitry inside the generator may not be able to take such a high volume of current. And the cable will simply overheat and then it will cause short circuit, it will burn, it will ignite. So in your answer, please indicate that when the speed is not controlled, the rotation will go so fast, and when the rotation goes too fast, the current generated will be really huge, and the really huge current will actually overheat the cable and cause failure. Okay. For part D, they tell you the rotation 2.5 times in each second. Actually, this indicate the frequency. So with this frequency, go and work out the period, and with the period, you know that okay, my wave has to complete one wavelength within 0.4. And then they tell you the rotational speed 15 meter per second. With that 15 meter per second, go to your graph here. So 15 meter per second is actually your top speed. So look at this chart. So at top speed, you are actually getting output voltage of 48 volts. So once you know the voltage, you can then indicate it's going to fluctuate between positive 48 and negative 48. So the next part is that whether the graph will go from 0 up, down, or from 48 then slowly down like that. So we need to find out. So how do you find out the information? You need to read this thing. So from this diagram, you know that the starting position is the horizontal position, and when you are at the horizontal position is actually where the magnetic flux between the two magnets is the most dense. So any small movement by the coil, it will actually experience a high rate of change in terms of the magnetic flux strength. Okay, so once you have that understanding, you will realize that the horizontal position will give you the maximum rate of change in magnetic field. So therefore, there will be the maximum EMF. So with that understanding, you can start drawing. So at first it will be max, then after that, of course, it will go down, then after that it will go to the minimum, then from minimum you have to come up and then complete. Yep. So that is one wavelength. Okay, and of course, if you have time, continue drawing it. Okay. Okay, part E, they tell you, actually I do it in a long way. There is a shorter version also, so I will show you both. So what happens is that they tell you the house energy requirement. So one day it used this much of energy. So what I did first is that I convert everything to kilojoules. So I know that my total energy is this much of kilojoules. Then I go and look at my table here, and I realize that my wind turbine will have an average annual energy output of this much, 1997. But you notice that this is kilowatt hour. So what I've done here is that from kilowatt hour, okay, because this is per annum, right? So this is 1 year. So I need to find out one day how much my energy output, so that I can compare with my energy requirement per day. This is energy requirement per day. So I divide this by 360. So I got the energy output from the turbine per day, but this is in kWh. So basically I convert this kWh into kilojoules. So how do I convert that? It's quite simple. You just multiply by 3600 and you get this. Okay, kilojoules. Okay, then you notice that okay, my energy output by the turbine is insufficient to support my energy requirement per day. So of course it is not advisable. Okay, another way is that you see this is a volt, they give you the hour. So what happens is that what you can do, you change this into kilowatt. Okay, and you just take this kilowatt multiply by this hour, it will give you 3.6 kWh. So you do the same thing for the radio, for the water pump. So when you sum this up, okay, your total energy requirement per day for your house will be in kWh, and you can compare directly with this value. So you don't need to go through this thing. Oh, sorry, you can't compare it to this value because it's annual, it's per year. You divide it into 360, you can directly compare to this. So actually a quick glance, you can see that just the lights take up more than 50% of the energy output already. So anyway, that is another approach. Okay, part F, I actually got it wrong. That is because I actually understood the question requirement wrongly. So the question actually wants you to identify why work is need to be done to produce the current, and actually the explanation is quite straightforward. Work needs to be done because it needs to overcome the resistive force, okay, arises when the magnetic field from the permanent magnet interacts with the magnetic field from the current carrying coil. So if I refer you to this diagram, so what happens is that between the permanent magnet there will be one magnetic field, and as you rotate this coil, the coil itself from the induced current will actually produce its own magnetic field. So the magnetic field produced by the induced current here will actually want to oppose this movement, and your generator can only generate current if you provide enough work done to overcome this resistive force. Okay, so that is the explanation. Maybe you all can't see, right? So I write it down. So what happens is that when this is the coil, when you first rotate the coil, okay, let's say you're rotating it clockwise, so clockwise F, clockwise F, B, okay. So when you rotate clockwise, there will be an induced current here. So this one is your induced current. So this induced current is going to produce its own magnetic field. So the magnetic field produced here will be, can I get another different pen? Okay. There will be a magnetic field going this way. Yeah. Okay. Now this magnetic field will interact with the magnetic field from your permanent magnet, because down here you have your magnets. So what happens is the magnet will have its own magnetic field as well. Right? Magnet will have its own magnetic field. So by Lenz's law is that the induced current will produce a magnetic field that will resist the movement. So that's why you need to supply work to overcome this resistance to movement. Okay, that means this magnetic field will want to resist the clockwise rotation. Okay, so if you don't supply work to overcome this resistive force caused by the interaction of the magnetic field from the induced current and the magnetic field from the permanent magnet, your generator won't be able to move. Okay? Okay, last question. Last question is about your refractive index. So what happened? What happened is that first they ask you why refraction happened, and you need to give me 1 second. Yes. And okay, sorry, my dog is scratching himself vigorously, so I have to attend to him first. Okay, now continue with part A. So what happened here is that the question wants you to explain why does refraction occur, why the light actually bends. So there are two parts to it. Number one, you must be able to indicate that the optical density of A is larger than the optical density of A. And because of this difference in optical density, the speed of light traveling in these two medium is going to be different. And because of the difference in speed, it will cause the ray to bend. Okay, but if you want to be very precise and very accurate, it's not enough to just say that it is different. Okay, you have to be able to indicate that the light speed is traveling slower in A than in A, and therefore the light actually bends away when it goes into your air medium. Okay. For your part B, just be very careful. Okay, if you look at your diagram, okay, your angle X, is actually not your angle of incidence, because if you draw the normal, you notice that this one, the shaded one, is your angle of incidence. So take note of that. Your angle Z, in this case, it is your angle of resistance. So don't need to do anything to it. Similarly, for your angle Y, that will give you the angle of refraction here. So with this, using your data in the first row, you can actually find your refractive index. Okay. So this is the working. I think I do not need to really explain it. Yeah, okay. So this angle I got. Okay, after you do all the calculation, you find that the angle of incidence in the second set, for the second set of data, is actually 31.9. But that is not your angle X, because the 31.9 happens here and your angle X is here, so you need to minus off 90. Okay, so that's how you get your 58.1 here. How do you get your angle Z? Your angle Z will actually be equals to your angle of incidence, because this line and this line will always be parallel, because they are traveling in the same medium, which is your air. For your part C, please refer to your book. I don't really want to sketch and then write it out. It is just you study your content, you'll be able to answer this. Part D, similarly, to find the minimum angle for total internal reflection to happen, this minimum angle actually refers to your critical angle. So if you want to find a critical angle, use your critical angle formula, you will be able to get it. Okay? Okay, I think this is really the last one. Ultrasonic wave, ultrasound wave, go and find out from your book. At which point is the water deepest? Definitely it is deepest when your time taken for the echo to come back will be the longest. So just explain that it is Q, it is because it takes the longest time for the echo to travel, and so the pulse must travel the longest distance. Okay, for part 2, be very careful because we are using echo, so this distance is actually 2 times the depth. So you must have this. And be very careful, they are actually talking about point P, okay, not point Q. Okay, so this is point P. Down here, they are just testing you on finding parameters from these two graphs. So in these two graphs, you need to know that when your x-axis is your time, you'll be able to find the period just by reading this. So one complete wavelength takes 2 seconds. So from here you can find the frequency. From 12.5, x-axis is actually the distance travel. You can actually find the wavelength. So this is your wavelength, 5 meter. Okay, be careful. This can be millimeter, can be other things. So make sure that this is your SI unit meter. So with that, V equals F lambda, you will be able to find the speed. Okay, down here I didn't draw anything because it is quite straightforward. Double the frequency means that you have to double the frequency. half the loudness means that your amplitude need to be half. Okay, so I just give you a quick sketch. Notice that this is distance. So initially, you have a wavelength of 5 meter. Okay, so your wavelength, will it be affected by your frequency? Will it be affected by your frequency? So if you are not sure, right, if you don't know, you're guessing, do not stop there. Do not just think that it's guess. Do not just stop by guessing. So go and write it down. You think that, okay, if I reduce my frequency, change the loudness, will the speed of sound be affected? No, right? The speed of sound will only be affected by the medium that the sound is traveling in. So you know that V is constant. So V is constant. So what does V equals to? V is actually equals to F lambda. So now your sound wave doubles its frequency. So F is actually being doubled. But my V is constant, right? That means my wavelength must be half. If not, I can't keep the velocity constant. So even though the frequency is being doubled, your wavelength will be half. So now initially your wavelength is 5, right? So it will be half now, so it will be 2.5. Okay, and your amplitude now is being doubled, right? Your amplitude is being doubled. Initially your amplitude is 10, so now it will be 5. So write down 5 is -5. So what happened is that you now have to complete one wave within 2.5 meter. So complete it. So you will have a wavelength that goes like really small, like that. Okay? So do not stop with just your guess. Okay? Try to put it into formula and ask yourself, okay, if now my V is constant, my F is double, what happened to your lambda? Okay? Okay, that's it. That's all.